Hello, hi everyone, welcome back to the channel and welcome back to yet another playlist or yet another series. So in this series I'll be covering the most popular blind 75 problems. So I'll be explaining each and every problem of this playlist, this series or this list, we can say blind 75 list. Basically up discussing multiple approaching of solving a particular problem, starting from the brute force one, then eventually moving on to the most optimal solution, and finally we'll code the most optimal solution and we'll discuss its time and space complexity as well. So why this list is so popular? Because this list is covers the 75 most popular problems, and these problems covers the maximum patterns which we can expect during the coding interviews, right? So I found this list here at this resource, that is at lead code discuss section, and we can see that there are multiple sections. We have problems on arrays, binary, then we have problems on DP, graph, interval, linked list, matrices, strings, tree, heap, etc. So these 75 problems are one of the most important problems that you must cover to ace your technical rounds, right? So in this video lecture, this is the introductory video lecture, and in this video lecture I'll be solving the very first problem of this list, and the very first section is array, and in this section the very first problem is this two sum, this problem, and this problem is tagged easy, and this is also problem number 1 on the lead code, right? So let's see what the problem statement is. So I hope you are enjoying the videos which I am uploading. So make sure to comment your views, make sure to give your comments, make sure to give your opinions on my videos. If you like some features, if you do not like some things about the videos, then please do let me know, because that thing will let me improve my content in the future, right? So let's start with this problem. Given an array of integers nums and an integer target, we have to return the indices of two numbers such that they add up to target, right? So basically we are given an array nums, we are also given a target, and we have to return the indices of those two numbers which add up to that target which we are given. Now you may assume that each input would have exactly one solution, right? That means we cannot find more than one pair, right? There will be exactly one pair, and we may not use the same element twice. Means we cannot use a single element more than once to get our target sum. Like we have to choose two distinct indices so that the elements at those indices add up to the target value, right? So these are the two constraints that we are given, and the input array is designed in such a way, the test data is designed in such a way that will have only exactly one solution, right? We cannot have multiple pairs which sum up to the given target. We have exactly one pair for one array, right? And we can return the answer in any order. Means the order of the pair which integer should come first does not matter. Okay, so let's understand the problem statement using an example. So let's take the very first example which we are given, which is 2, 7, 11, 15, and the target that we have to find is, the target is 9. So find two numbers in this index 0, 1, 2, 3. Find two numbers which add up to this value. We can see that these two numbers are 2 and 7, because 2 plus 7 is 9, which is nothing but our target. So the answer would be 0 and 1, or it can be 1 or 0. Remember, the order of these pairs does not matter. So this is also the answer, this is also the answer. Both of them are valid. So this is what we have to do in this problem. This is the popular two-sum problem. So how are we going to solve this problem? We can see that the array may have negative elements as well, and the length of the array is at least 2. We cannot have an array which is less than 2 elements, because in that case we cannot expect a solution. Fine. So the second condition is that we cannot do, let's say we had an element, let's say the array is like this, 2 4 3, and the and the target is 8. We cannot do something like this, take 4 2 times, 4 plus 2 4, and it makes 8. This is not allowed. We can select an element exactly once. Each element can be a part of at most one pair. Fine. So let's see how we can solve this problem. The naive approach to solve this problem, or we can say the brute force solution to solve this problem, is easy. It's basically considering all pairs which we are given. So 2 7 11 15, target is 9, and we have to select, let's select all of the possible pairs. So start with 2, then select this pair 2 7, then select 2 and 11, select 2 15, then move our first pointer to 7, and now club this 7 with rest of the numbers which are present on the right half of the array. That's the strategy. Okay, so take every number starting from the first number of the array, and for that number try to club that number for the rest of the numbers in the array. Like for the very first case, I clubbed 2 with 7 11 and 15. Here I found 3 pairs, and I can see that I found my answer right here, so I returned the answer right here. But we may have a case like this. Let's say 7 11 2 15 7. So let's say the case is something like this. In this case, I will start with 11, then I'll try to club 11 with the rest of the elements. So let's say this is pointer I, and I take a pointer j which starts from the element which is just next to the element at position I, that is from 2, and I try to club this I with this j. So club 11 with 2, then move j here, club 11 with 15, then move j here, then club 11 with 7, right? And try to check for every pair if the sum is same as the target which we need. So 11 plus 2 is 13, no. 11 plus 5 is 16, no. 11 plus 7 is 18, no. So all of these three are not the sums, right? So then move our I to the next element, move I here, and now start the I is here, move j from the very next element of the array, move j from here. Now try to club 2 with the rest of the elements, 2 15, then 2 7. 2 15 is 17, 2 7 is 9. So we can see that this is my answer. So when I get the answer, I will return the indices I and j right from there, because I need to return the indices for which the elements sum up to target which we are given, right? Now how we can implement the solution? The solution implementation is simple. All we have to do is use a for loop to iterate over the elements, start from I to all of the elements. Then inside this for loop, use one more loop which starts from an element which is right next to the ith element, j less than n, j plus plus, and then check if the sum of the element at I and element at j is equal to the target. If this is the case, then return I and j pair right from there. That's all. That's all we have to do in the brute force solution. So what is the complexity of this solution? We can see that we are using nested loops, loop inside a loop. So that will take, so this loop has a complexity of big O of n, and inside the loop has a complexity of big O of n, which gives me the overall time complexity of big O of n square. And that is my, this is my time complexity for this solution. The space complexity is constant because I'm not using any data structure. So now this solution will really not work for the constraints which we are given here. We can see that the constraints which we are given here are the length n goes up to 10 raised to the power 4. So the operations the worst case operations would be 10 raised to the power 8. And we can see that it will take me roughly 1 second for this type of input. Like it will take me 1 second for my code to execute over this type of input and output the results. But we can do better, right? We can do better than big of n square. How we can do that? Think about it, think for a moment, and then after that start from here. So like we can see one of the solutions to solve this problem, let's say 2, 11, 7 and then 15, the target is 9, is basically what we can do is we know the target, right? We already know the sum of the two elements a and b which are there in this array. So this a and b are present in the array. So what I can do is I can start iterating from this element, from the very first element of the array, and let's say it is I and the name of the array is ARR. Then what I can do is I assume that, let's say, one of the array in the answer pair is this current element on which I am standing. So I am standing on this element. So assume that one of the elements like a and b, either a or b, is 2. In that case, what should be the other element? The other element must be t minus ARR of I, right? Because the sum of this element and the other element is equal to t. So if I subtract this current element from the sum of those two elements, then I will get the second element of the pair. Now the job is to find this element in this remaining array, whether this exists or not. If this element exists, then I have successfully found my pair. Otherwise I couldn't find my pair successfully, right? So that's the thing. So how can I do that? The solution is simple. What I can do is I can basically use a hash map. We know a hash map stores a key value pair. Now here the key will be the elements of this array and the value will be their indices, right? That means if I store the elements in a map, so for 2 I will have 0, because for the very first element it is present at index number 0, 11 is present at index number 1, 7 is present at index number 2, then 15 is present at index number 3. So we have this hash map prepared for us. So what I can do is I can start from the very first element and I can subtract that element from the target, and this is my remaining element which I can look for in this hash map, right? So look for this element in this hash map if it is present or not. So this element is 9 minus 2, which is 7. Check if 7 is there. Yes, 7 is there. It is present at some valid index. So all we have to do is pick the index of the current element, which is 0, pick the index of this element 7, which is 2, and return this pair. That's all we have to do. Fine. Just make sure that we are not using the same element twice. That's what you have to make sure, right? We should not use the same element twice. Fine. So let's just code this solution. This is my optimal solution. what is the time complexity for this solution? We can see that we are iterating over the array exactly once, which takes big of and time complexity. And for every element, I'm looking up in the hash map for this element t minus arr of I, and a hash map takes log of n time complexity. So the time complexity would be n, and for every element we use a lookup table which takes log of n time complexity. So the overall time complexity is of big of n into log n. And we can see that the space complexity would be big of n because we are using a extra data structure, that is a hash map. It's a container which we are using, right? So let's just code the solution for this problem. So I will code the solution in C++. So let's declare an unordered map. Let's call it MP. Now iterate over the elements of this array. Iterate over this array nums dot size I plus plus. If nums of, if we can see that the very first iteration, what I'm going to do is I'm going to map the elements of this array to their indices. So MP nums of I is equals to I, right? This is the first iteration. Let's call it map the elements to their indices. Now on the second pass, what we're going to do is we'll be iterating over the array again, over each element of the array, nums dot size now check if the current element, the target minus the current element, do have a valid index in the map. That is MP target minus the current element, which is nums I. If it does have a valid index in the array, if it is present there, and we also have to check whether this element, which is the second element in the pair, nums I, is basically not equal to the current index which we have. Okay, so in that case what we can do is, so we can see that we have a valid index. Then the second condition checks if that valid index is not the current index, because if it is the current index, then what we are doing is we are using the same element twice, and which is not allowed in this problem. So if both of the conditions are met, means this is our valid pair, the pair I and the pair where we have our target minus nums of I, right? So if during the iteration I do not find my pair, what we can do is I can return the empty array from the end of this function. So let's try to submit this. Okay, it got accepted. Let's submit it. Okay, so the solution got accepted, and we have already discussed the time complexity for this solution and the space complexity for this solution, and I hope you understood the logic behind solving this problem. We also have one more solution which uses binary search, but for that solution to work, the array must be sorted. Okay, so take that as an exercise. You have to solve this problem using binary search. So sort this array in the increasing order or in decreasing order, then try to use binary search to find the valid pair of indices. Okay, so the complexity for that solution, the binary search solution, will also be n log n. Fine. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and continue in this Blind-75 series. in which we'll be discussing the solutions to all of the 75 problems which are most commonly occurring patterns during the interviews. So I will see you soon in my next video. Till then, take care. Bye bye. And apart from watching videos, also try to solve problems on your own. So if you are a beginner, then you can start from Hacker Earth, you can start from Hacker Rank. After you learn a programming language, you can go to the basic C++ section and you can start solving problems right from there. Because you can start solving easy problems if you are a beginner coder. And also try to participate in contests like Code Chef Starters and Code Forces Div 3, Div 4 contests. That will improve your problem solving skills. So that's all for this video. I will